Hello, what I'm going to do today is I'm going to go through one problem where it's an ellipse, and I want to go through the process of completing the square to put the equation of the ellipse in standard form. And from that, we can find the center, the foci, and the vertices, and then we can plot it. So what you should have with you right now is on the back of the 9-1 helpful equations, I gave you the 9-2 helpful equations, but you should have this, which gives you the formula for the ellipse, the standard formula for ellipse. Two things that I want to point out. First of all, you have a horizontal ellipse, which opens, so it's kind of like a squish circle, and the horizontal ellipse opens so that the longest axis, which they call the major and minor axes, this would be the major axis, and by major, it just means that it's longer. So that's a horizontal ellipse. A vertical ellipse has a major axis that goes vertical. You're going to notice that the formula, these two equations are exactly the same. The only thing that changes are the A and the B. So when you put it in standard form, you're just going to solve the equation, complete the square, do everything like normal. But at the end, you're going to decide which one's your A and which one's your B, just based on which one is the larger number. So the A is always the larger number. And to find the foci, we're going to use this formula here. C squared is equal to A squared minus B squared. So let's go through one problem pretty slowly and see how it goes. So first of all, I'm going to clear some of this stuff out of our way so here I have an equation. How I can tell that it's an ellipse before I even start is that I have the x squared and the y squared. But what I notice about the x squared and the y squared, which is different from a circle, is that the coefficients are different. So in this example, I have 16x squared and the 25y squared. Those are different. So that's going to tell me that it's an ellipse and not a circle. I'm going to start it off the same way I did with the circle. I'm going to put all my x terms together, all my y terms together, and I'm going to complete the square twice. So to try and help you out, I'm going to color code. So I'm going to put my x's together, put my y's together. Anything that doesn't have an x or y, which is a 16, I'm going to take to the other side and make it negative 16. Now, because they're different, I can't divide everything by 16. I can't divide everything by 25 like I did with the circle. So I'm going to have to factor out for both the x and the y. So in this case, I'm going to factor out 16, make it 16 times the quantity of x squared minus, and then 16 times 2 will give me that 32x. I'm going to complete the square, so I'm going to leave myself a space to fill in when I complete the square. When I look at the y's, I'm going to factor out a 25 because that's the coefficient in front of y squared. 25 times 2 will give me that 50. Again, leaving that space. Oops, I knew the answer, so I started to write it. And then is equal to negative 16. Now, when I look at this one, I'm going to complete the square. This 16 is just sort of going to come down for the right. The process is exactly the same. I take the square root of x squared, which is x. Since this is a minus sign, I keep that minus sign. Then I look at my middle term, which is 2. Take half of 2, which is 1. That's the number that I'm going to put there. I'm squaring this. In order to make this a perfect binomial squared, I'd have to take 1 squared and I'd have a 1 here. So this x minus 1 squared will be this x squared minus 2x plus 1. But when I added this 1 in here, I technically added inside this parenthesis. I technically have to distribute the 16. So I really added 16 to this side of the equation. So if I add 16 to the side of the equation, I have to add 16 to the other side of the equation. So we're going to do the same thing with the y's. Again, just copying down that 25. That's not going to change how I do my binomial. The square root of y squared will be y, because this is a minus sign, this is a minus sign. Half of 2 is 1, so that'll put a 1 here. 1 squared is going to be 1, so I'm going to put a 1 here. But again, I'm not really adding 1, I'm adding 1 inside this quantity that technically I'd have to distribute the 25 to. So I'm really adding 25 to this side of the equation, which means I add 25 to this side of the equation. And that is equal to 1. Oh, no, it's not. I'm actually taking 25. Negative 16 plus 16 is 0 plus 25 is 25. Now, when you look at your formula sheet, and I'll bring it out here, I'll peek it out here for a second. When you look at this formula sheet, one thing you should notice is that they're always equal to 1. See how they're always equal to 1 here? So when I go to do this, I'm going to want to set my equation equal to 1. So whatever number I have this formula equal to, in this case it's 25, I'm going to divide everything by 25. That'll set it equal to 1. So when I do that, the right side is very easy. 25. Whoa, why did it go backwards? Oh, technology. Hold on. Be patient with me. I think I can edit this out. That's 25 here. So when I divide this by 25, that'll be 1. These 25s will simplify, and I'll be left with y minus 1 squared over, and I'm just going to put that over 1 because they're fractions, so I'm just going to set up like a fraction. When I get here, though, 16 and 25 don't have anything that I can factor out of both. There's no common factor, and they don't simplify easily. So what I have to have this coefficient as a 1. So I asked myself, what do I have to multiply 16 by to get 1? And I decided I'm going to multiply it by 1/16. If I multiply this by 1/16, I have to multiply the denominator by 1/16. So I'm going to have x minus 1 squared, and then when I multiply this, I'm going to get 25 over 16. So that's my standard formula. From this, I can tell that my center is, again, this is my H and this is my K, just like before with the circle. My center is going to be 1, 1. That's easy. Now, I see that I have two denominators. I have to decide which one's larger. So I'm looking at 25/16 and 1. So which one is larger? And you should tell me that you know, well, we probably should find the square root first. So, yeah, so that, well, so I'm going to decide which one's larger. So I have 25/16. So I'm going to say that's larger than 1 because 25 is larger than 16. So a squared is equal to 25 over 16. So the square root of a, where are you going? Oh. Square root of a, square root of 25/16. So I'm going to have a is equal to 5/4. When I go to do b, b squared was equal to 1. That would be b squared. So b squared was equal to 1. So b is equal to 1. And then I'm going to look at my formula sheet and see that c squared is equal to a squared minus b squared. So c squared is equal to 25/16 minus 1. So c squared is equal to 9/16. So c is equal to 3/4. So when I go to graph, and so, and since I want this to show up, I am going to make every line worth 1/4. That'll make it easier for you to see. So 1, 2, 3, 4. This will be 1, 1, 2, 3, 4. This will be 2. 1, 2, 3, 4. This will be negative 1. 1, 2, 3, 4. This will be positive 1. Just so you can see. So my center is, I said my center was 1, 1. I'm going to plot the center at 1, 1. That's my center. My A, which when I look at this, my A, when I go back up to my equation, that's 25/16 or the square root 5/4 goes with the x. So when I go to graph it, x is a movement to the left or the right. So I'm going to go 1 1/4. So this is 1, 2, 3, 4, 5/4. 1, 2, 3, 4, 5/4. So those are my vertices. To write the ordered pair for my vertices, and I only have to write the one pair, those would be my major vertices, I'm going to take the center 1, 1, and to the x, I'm going to add and subtract 5/4. So I'm going to have, you can either write 9/4 1, of the vertices. And then the other one would be -1/4, 1. Or you could do 2 1/4, same thing. To help me sketch the ellipse, I'm going to look at my B, which is 1. So based on my center, I'm going to go up 1 and down 1. I know I'm going up and down because that B went with the Y. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4. So to sketch my ellipse, I'm going to connect those dots. And that's my ellipse. The foci actually, I said C was 3/4. So the C is the distance from your center to your foci. So I'm going to go from my center, go 3/4, 1, 2, 3. Other direction, 1, 2, 3. Everything happens on the major axes. So whatever axis is longest, that's where your foci are. So these are going to be my foci, and the order here for my foci. Again, I'm going to add and subtract this 3/4, add and subtract this 3/4 to the x coordinate. So I'm going to have 1/4, 1, and then 7/4, 1. Now on a circle, the foci in the center are the same, but since the coefficients are different, your foci are going to change. And that's how you graph an ellipse. We'll go over this more in class, but I hope this helps.